Good day, everybody. Brad Steele here, NASTD President and Commonwealth of Massachusetts Senior Director of Unified Communications. As part of the NASTD curriculum, we had been looking to put together some training material for folks, some 101, so to speak, on different technologies as they come up, and got derailed a little bit by the COVID-19 outbreak and had to change tack a little bit. So we have done that. So we are here with the first of our training sessions that we hope to put in front of you. And hopefully we'll have about one a month of these that we're going to put together and send out. What we've selected for our first subject is SD-WAN. SD-WAN is one of those things, came out not too long ago, came out and people were starting to talk about it a lot, and there's a lot of confusion over what it is, what it isn't. So I reached out to the corporate community and we were able to get Mike Frane, Vice President of Product Management with Windstream, on the call with us. And he is going to go through our 10 questions that we're going to ask about all of the products that we cover. So Mike, hello.
Hello, Brad. Thank you very much for having me on today.
Excellent. So we're going to get right into it, and again, it's simple questions that hopefully that everybody has wanted to know the answer to, and that Mike can give us. So we're going to start off with the basic question, which is, what is SD-WAN?
So SD-WAN stands for Software Defined Wide Area Network. And humbly, it is the next network that everyone's going to use. We started with SneakerNet, moved on to X25, ATM, Frame Relay, and we landed on our current gold standard, which is MPLS. MPLS is rigid, whereas SD-WAN was designed for agility to enable organizations' digital transformations and changing application consumption models to the cloud or software as a service. SD-WAN provides a highly dynamic and agile platform for organizations that they can use to deliver really exceptional application performance over the network. And unlike MPLS, SD-WAN was designed to be able to leverage a wide variety of access types and really shines when broadband is used as one of those access types.
Okay, so that leads right into the question. So what is it used for?
It's used to connect multiple locations in a network together, to each other, to a data center, to applications and data in a cloud or a SaaS platform. It leverages multiple cost-effective access types at each location, and it's able to dynamically shift the application flows over the best performing elements in real time. It adjusts to the challenges that lower capacity and broadband networks can often present. Simply stated, if you have one broadband connection that's experiencing high jitter or packet loss, it will shift the traffic flow to another circuit which maybe isn't experiencing those same issues. So you can leverage multiple commodity access types to provide a really highly reliable network. We're also seeing it used in standalone locations to improve the resiliency and performance of the location using multiple access loops. Right? So it doesn't necessarily have to network locations together, but you could have a single site, or you could have an organization with a single location that just needs a little bit higher resiliency or better performance. So leveraging multiple access loops in that case helps dramatically. And we're also seeing it in single circuit deployments. The technology that we use specifically has forward error correction and jitter buffering and other capabilities that it can actually improve the performance of a single broadband connection without having multiple broadband loops. But by and large, the real promise of SD-WAN is multi-location, multi-access networking capabilities.
Okay. And the next two questions kind of go hand in hand. So if I were looking to do this, what would it replace within my network, or what would it supplement? And what are the use cases for implementing SD-WAN?
Great questions. So if you recall from the early days of SD-WAN, MPLS was dead. We do not believe that MPLS is dead. We believe MPLS has a very long tail. However, we do believe that MPLS is getting long in the tooth. So SD-WAN can replace or supplement existing WAN technologies. The greatest promise is that SD-WAN will replace all the private connections with internet connections connected to the SD-WAN device. They can be DIA, Ethernet, broadband, cellular, you name it, SD-WAN can use it. That gives you the most flexibility in terms of deployment as well as management. But we're still seeing the majority of our SD-WAN deployments leveraging a hybrid approach. Organizations keep their tried and true MPLS networks in place and supplement with DIA, broadband, or cellular, with SD-WAN really controlling the application for the application flow for optimal end user experience. In these cases, right, the use case you asked about, it's typically the organizations have hit the wall on MPLS. They don't want to move up to the next tier because it's a lot of money, as we know. So deploying SD-WAN over the top of DIA or broadband to get the higher bandwidth for their end users is one of the use cases. So it's when we look at it, customers organizations are shifting their application workloads, right? Something's changing. There's a dynamicism in their business. So a lot of it is digital transformation, and as we know, digital transformation, one of the currents there is the cloud connectivity, right? So they're moving where their applications are being housed. They're changing the consumption model. As they do that, right, as they move their applications to either the cloud or a SaaS provider, they need higher uptime and resiliency, right? It's no longer a box that they can walk down the hall and kick when there's a problem. It's now hosted someplace else, and so that the high uptime and resiliency that SD-WAN provides using multiple access types is a huge use case for these customers, and it also allows them a lower cost per meg. Right, and I want to caution the team here, or the group here, that you'll often hear that SD-WAN lowers your costs. SD-WAN absolutely lowers your cost per meg, but what we find is that customers and organizations spend about the same, or in many cases a little bit more for SD-WAN, but they have much higher throughput and much higher uptime for that additional spend.
So it's a better value.
Better value, yes, exactly.
Excellent. So you said, the box down the road, et cetera. Is there any hardware that I would need to procure to implement SD-WAN?
So there is hardware that you need to procure, because the majority of traffic issues that you run into are going to be in the last mile. The vast majority of SD-WAN deployments, there are some that'll say that it's all cloud-based. I don't believe them, but that's beside the point. Some will say they're all cloud-based, but the vast majority of SD-WAN deployments have some type of device on premises. And the hardware that you're going to need is going to be dependent upon the vendor you select, the topology of the network, and whether you engage a managed communication service provider or not. When you think about SD-WAN, you can separate it into two different planes, a control plane and a data plane. For the control plane, you'll have to invest in the orchestration hardware and software. This is really the brains of SD-WAN. That's the central control point for management and is needed for all your SD-WAN deployments. The data plane will have different hardware requirements depending upon the network topology. And there are fundamentally two different network topology models, a hub and spoke model and a cloud-based model, though there are also hybrid models as well. In the hub and spoke model, you'll need hardware at each one of your locations. In most these cases, the hardware is in the form of an appliance, though some SD-WAN technologies leverage x86 CPE or have software-only deployments that allow you to deploy software packages on compute and storage that you already have at the premises. Now, in the hub and spoke model, your traffic is acted upon by the SD-WAN technology between your remote locations, the spokes, and your hub location, which is typically your data center or headquarters. This is a great model if you need to interconnect multiple private networks together, or if you house many of your applications in the data center or at your headquarters still. Essentially, in this model, you need a piece of hardware at every location, because SD-WAN is bookended, so you need it on both ends of the data flow. In the cloud-based model, you still need the hardware of some type at each one of your locations, but there's also compute required in the cloud. And the cloud can be from your technology provider, or it could be from a managed communication service provider. Rather than sending all the traffic in your SD-WAN back to your data center or headquarters, the cloud model is designed to reduce your network dependency on those locations and provide offload for that traffic. If you think about the use case where you're sending more and more of your applications out to the cloud, why do you want to send it to your data center just to get out to the cloud, right? So the cloud model is really designed to reduce the reliance on your data center and headquarter locations. And that allows you to reduce the capacity needed to those locations and provides a more controlled application experience to your cloud services or SaaS provider. The cloud model, cloud-based SD-WAN model is the preferred model for those organizations who are really embracing the digital transformation and want an optimum end user application experience.
Okay. So as I'm moving forward and looking to implement this, what do I need to consider before I start doing the procurement process?
So the first one is blocking and tackling, right? Make sure you understand where you're going with your applications. Don't try and design a network that fits what you have today. Design the network for where you want to go. As I stated, there are multiple modes of SD-WAN deployments, and you can evolve them over time. We have many customers who move from a hub and spoke model because maybe they have MPLS with another provider, and then once they get their network deployed, they deprecate their MPLS and convert those to internet, and then we move them to the cloud-based model as they've traveled along their digital transformation journey. So I would say, make sure that the technology you choose and the partners that you're bringing into the fold are capable of evolving along with your business. And secondly, and this is very important, do not believe the simple hype that comes part and parcel with the SD-WAN marketing. Deployed in a simple greenfield environment, SD-WAN is very easy to install. I installed it in my house 3.5 years ago in about 5 minutes. It was great. I did not care that my entire network got re-IP'd. I did not care that anything else changed, right? Which is not typically going to be the case of an organization who has static IP in a lot of their locations or specific IP schemas. So make sure that you take the time to do your diligence and to plan effectively.
And so that ties into my next question as well, which is, are there any limitations, restrictions that we need to be aware of?
So the limitations, restrictions are really going to be based on the capabilities of the underlying technology. And beware, there are many technologies vendors in the market today who are peddling SD-WAN. Make sure that you do your homework to understand not only what they say that they can do, but how the technology actually does it. There are, the number one thing that I can think of is dynamic path selection, right? You've got those technologies out there that have dynamic path selection based on session flow, and then those based on packet. So if you think about this, if you have a degraded circuit and you have packet flow technology, the next packet is going to flow over the better circuit, right? Whereas if you've got a session-based technology, your next call might flow over the better circuit, but your current call is still going to go over the bad circuit. I'm not sure if I can swear here, so I'm just going to say bad. The bad circuit. So it really comes down to, like I said, making sure you understand how the technology actually acts upon your traffic to make sure that it's going to do what you want it to do.
All right, and you set it up in your house in 5 minutes. I'm assuming your house is slightly smaller than my data network here in the Commonwealth, but what should we plan on for a time frame of implementing?
So, like I said, if you already have the access in place and you have a very simple deployment, it's a matter of days, right? And I'm including shipping from wherever you need to get it from. The actual on-site time can be minutes. However, there's a lot of design and planning that has to go into a deployment, and the time up front really pays dividends when it comes to actually turning up a network. Assuming that you can deploy SD-WAN to interconnect 3 different MPLS networks in a week is not good planning. There's a lot of work that has to go in when you try and interconnect multiple networks together or multiple technologies together. And obviously, if you need to order and deploy access, that's usually where the long pole intent's going to come in. So We have customers who deploy SD-WAN over the top of what they have today, and then as they get the new access in, we'll integrate it in. So I guess that's a fairly long way of saying it really depends. It depends upon what you have in place today, how much of it you're changing versus how much of it you're keeping in place. And again, the amount of time you spend up front, either with your technology provider or with the service provider, depending on how much path you choose to go down, is going to pay dividends. And there are a lot of questions that get asked. And one of the big eye openers for me with SD-WAN 3 years ago, when we started rolling it out, was there are a lot of networking groups out there that hold things close to the vest, and as they hold it close to the vest, skeletons start to come out of the closet, and it's an interesting dynamic when we're in the sales process, because we need to push to understand information, so that we can design it so that it works the way that the organizations want it to. But we also find out that a lot of organizations just don't know, right? So we'll ask them the same question 4 or 5 times throughout the enrichment process, and they'll finally come back and say, "Look, we don't know." And so we actually have a professional services group that can kind of parachute in and do a lot of network discovery. But it's important, I guess. Don't look at if you're leveraging a managed service provider or a VAR or however you go about this. Don't look at us trying to question you or your capabilities, but we're really just trying to understand what it's going to take to deploy this, because we want to have the best rollout possible for you and for your end users. So that's an even longer explanation to say it depends.
Hence. So probably the most important question for all state entities is the next one, which is, how does the cost structure work for SD-WAN? What do we have for single time costs, and then what do we have as a recurring cost going forward?
So the structures are going to depend upon the technology vendor and the partners that you use, whether VAR or managed service provider. But it'll typically be an option of an upfront cost for the hardware, and then recurring costs for the maintenance charges on that hardware, along with the SD-WAN licenses. Most of those licenses are going to be based on bandwidth, where in other cases, depending upon the vendor, it's going to be based upon the CPE that you select, or the devices that you select in the design. The other option is monthly recurring charge for everything: hardware, maintenance, software, all rolled in together. And then there'll also typically be incremental charges for premium support if you go the DIY model, the do-it-yourself model, or monthly management charges if you opt for a managed communication service provider. And I would say that it really depends on the profile of the buyer. There are some organizations out there that are measured on EBITDA. So spending more CapEx or spending more capital, buying more hardware up front is better for them. There are others who are really just focused on not necessarily as focused on EBITDA. So having that same monthly payment over time is more advantageous to their financial system and how their organizations are set up. So most vendors out there are fairly flexible. I think back at the inception, everyone was thinking we're going to go to a monthly model only. There's no upfront costs anymore. But we've found that typically isn't, that one size fits all typically fits about half. So in our pricing models, we have both, where you can buy components up front, and then you can pay a lower monthly, or you can pay everything on a monthly rate for a slightly increased rate.
Okay. I'm going to go off script a little bit. I hope I don't throw you too much here, but our organization has the word security built into our name. Mm-hmm. So the one thing I neglected to have here on my questions for you is, are there any security concerns? Is it better security, worse security than, say, an MPLS network? And is there anything different that we need to think about on the security front?
So it's a fantastic question. It's a discussion that we have. I would say that we don't have an SD-WAN discussion that doesn't include security at some point, because as you introduce more internet into a network, obviously the security teams get a little jittery is probably not the right word, but their ears tend to perk up a little bit more.
Maybe jittery is a good word.
We have the security conversation, and from a private connectivity perspective, it's government grade encryption between all the locations. So the data in motion isn't an issue. A lot of the discussions we have around security actually come from like premises-based firewalling or cloud-based firewalling, right? MPLS was great because there was no way to get into it. Like unless you were there, right, at the location,
yep.
You couldn't get into MPLS. Now, introducing all these internet points obviously brings the security into the discussion. Many of the technologies out there have security integrated in, spanning from stateful firewall all the way up through next generation security. Some have VNF capabilities where you could load a best in class firewall into the device. Obviously you have other options. You're putting a next generation firewall out at the premises, or leveraging next generation firewalls in the cloud, right? And that's really where like the SD-WAN cloud design shines. We have a lot of our customers leverage our security platform or security capabilities in the cloud. And in that case, all the traffic just comes back to the cloud, and we offload it depending upon where the customer needs it to go. And you can also have discussions around VLANing at the premises, because not, as I like to say, not all traffic is created equal. You don't necessarily need to be running IPS on traffic that's coming out of your cafe, right? If you've got free Wi-Fi for your cafe patrons, you don't necessarily need to be running IPS on that. You can have different security models for different types of traffic, which again is going to depend upon the capabilities of the technology provider themselves, as well as any other partners that you may choose to bring into the design.
Okay. And final question: what else do I need to know?
So I read this a little bit as lessons learned, and when I think about what we've done over the last 3 years, right, with thousands of customer networks designed and deployed in an operation, tens of thousands of endpoints or locations, I'd say that the number one thing that the number one piece of advice I can give you is, don't let the way that you've always done things relative to your network influence your move to SD-WAN. Really embrace the technology for what it has to offer. Explore the dynamic nature of it, and look into how you can use that dynamic component to improve your operations. Don't let SD-WAN become your MPLS 2.0 deployment. Right? You're not going to be happy. Your end users aren't going to be happy. Your leadership isn't going to be happy. And I know it's hard, right? Because we've been in the MPLS era for so long. Trust me, I was MPLS product leader for 15 years. So but you really kind of have to take those boots off at the door and put some different shoes on as you walk through the new house that's SD-WAN, which is also why I should not do analogies as I'm talking. I should write those down.
Well, excellent. So that's all of the questions that I have. Very informative to me. I hope it is to the rest of the NASTD community. Folks, if you found this interesting, please reach out to me, either through the NASTD website. Let me know if you enjoyed this, if you found it helpful, if you'd like to see anything more, and more importantly, if you have any other subjects that you would like to see broached. We're going to look for our next installment of this, we're going to actually look into hyperconvergence, or as we like to call it, hyperconfusion, because at least nobody's been able to explain it to me yet where I haven't been confused. So anyway, again, reach out to me through the NASTD website or at my email, brad.steele@mass.gov, and let me know what you think about this and any suggestions you have. Again, thank you, Mike Frane, again, Vice President of Product Management at Windstream. Thank you for your time and your expertise on this. And folks, I look forward to seeing you, or at least e-seeing you very soon. Stay well.